Hi everyone. In last class, we have discussed with the problems on module 3, that is stability, and also we have discussed regarding type 0, type 1, type 2 system for step input, and also we have discussed first order and second order system, right? Today we shall discuss that is model 3 questions only. These questions s to the power 6 plus 4 s to the power 5 plus 3 s to the power 4 minus 16 s square minus 64 s minus 48 equals to 0. They have asked to find the number of roots of this equation, positive real part and negative real part of CO real part. Okay, so next question is determine the range of K for the system to be stable using average criteria, that is G of S, H of S equals to K into 1 minus S, S into S square plus 5S plus 9. In this session, we shall discuss the two questions which is asked in the question paper in the year of February, March 2022. Okay, the 2017 scheme question paper. Okay, this is for electrical only. Okay, now we shall go with the questions. So you practice before you solve problems. You know read the concept of average criteria and also static error coefficients. Okay, type 0, what do you mean by type 0, and type 1, type 2, and what do you mean by second order system, and what is the standard equation for the second order system. Okay, so in this make list of formulas so that it will be easy to solve the problems. So this is what the question, what is it is in the question paper, right? So s to the power of 6, 4s to the power of 5, 3s to the power of 4 minus 16s square minus 64s minus 48 equals to 0. So first, what we write A0, A2, A4, A6. First row, always we write the even numbers. Okay, so we start from A0. So the question, the number s to the power of n is here, n is 6. So we have started s to the power of n is 6. So it's go on decreasing, s to the power of 5, s to the power of 4, s to the power of 3, s to the power of 2, s to the power of 1, s to the power of 0. But in this case, what happens is, here we two rows always we write from the equation itself, what they have given in the question. Okay, so now when you observe the equation, A0 value is 1 and A2 value is 3 and A4 value is minus 16 and A6 value is minus 48 and A1 value, next row, A1 value is 4, A3 value they are not given because s to the power of 3 is not there, so it is 0, and minus 64, that is A5 value, and A7 value, this is only this is only s to the power of 6, so A7 value will be not there, so it is 0. We have considered as 0. Next, A1 into A2 minus A3 into A0 divided by A1. So 4 into 3 minus 1 into 0 divided by 4. The value you get is 3. Next, 4 into minus 16 into minus 64 into 1 divided by 4. Okay, so 4 into 16 minus 64. It is Okay, minus of minus, this will become plus actually, and this is minus. So you'll get the value is 0. So 4 into 16 is 64, minus 64, and minus of minus you'll get plus 64. So it will become 0. Next, 4 into minus 48, minus 0 into 1 divided by 4. So you'll get minus 48 only. So 4 will be get cancelled. Okay. Next, 3 into 0. 3 into 0 minus 4 into 0 divided by 3. So you'll get the value is 0. Next, 3 into minus 64 and minus of minus 48 into 4 divided by 3. You'll get the value is 0 because 64 into 3 and 44 into 4. You'll get 0 value. So here the special case 2 is overall row is 0. Here the only element, one element is not 0, overall row is 0. So in this case what we consider is before the before the row. Okay, so this row is 0. So before that row, what it is there? 3, 0, minus 48. So that equation we consider 3 into s to the power of 4. If it is value is there, so we consider s to the power of 2. Okay. So no value is there. Here 0 it is. So we can take it as 3 s to the power of 4 minus 48 equals to 0. Next, when you differentiate with respect to s, what you'll get 12s to the power of cube. So that value what we got the after differentiation 12, that value you need to substitute here in the s to the power of 3 row. Okay. So instead of row, you need to replace as 12. So in the place of s to the power of 3 row, I have replaced it as 12. Okay, now you can calculate 12 into 0 minus 0 into 3. Again what you'll get, the value is 0. Next you multiply. Okay, 12 into minus 48 minus 0 into 3 divided by 12. For that you are getting minus 48. Okay, next value 12 into 0 minus 0 into 3 divided by 12, you'll get 0. Okay, this is 0 value and this is minus 48. Next 0. So here the one element is there, not overall row is 0. Okay, if the row is completely 0, then you should go with the special case 2, that is before the you should consider this row. Okay, before row you need to consider and you need to differentiate with respect to s. But here only the one element is 0. Here the value is there minus 48. You can consider the special case 2. So you consider the special case 1, that is you need to add epsilon. Okay, so you need to add epsilon in the first column, first this. Okay, for this. So what you'll get, epsilon into 0 minus 12 into 48 minus 48 divided by epsilon. This value what you get is 576 divided by epsilon. Next, final value what you will substitute for the s to the power of 0. Always we substitute s to the power of, for s to the power of 0, a to the power of n. That is here in this equation, a to the power of n is nothing but a to the power of 6. So a to the power of 6 value is here is minus 48. That value you substitute. Next, we don't know whether it is positive value or negative value. In order to find a stability, we need to know that whether it is a positive or negative. So one sign change and the system is unstable. Okay, here the positive to negative. Okay, here 576 divided by epsilon divided by epsilon, and this is positive value, and here we are getting the negative value. So one sign change and the system is unstable. So they are saying one time it has been changed. When you compare from starting s to the power of 6, all positive, here positive to negative. That's it. One time it has been changed. So one sign change and the system is unstable. Thus there is one root of s plane with a positive real part. So a of s equals to what you have taken the equation before, 3s to the power 4 minus 48 equals to 0. Here, in order to find the roots, it is difficult, right? So we can take it as s to the power 4 as s square. Okay. So s square equals to y we can consider. So in order to substitute here, so in order to find the roots of that, so we can substitute y here, 3y minus 48. Okay. 3y minus 48, 3y square, because it is s to the power of 4. So 3y square minus 48, y square equals to 48 divided by 3 is 16. So what you will get here, the value y equals to plus or minus 4. But the value of y is nothing but what? S to the power of 2. So s to the power of 2 equals to plus 4. S to the power of 2 equals to minus 4. For plus 4, what you will get? Plus or minus 2. And for minus 4, plus or minus 2j. Okay, so here you can observe is the only one positive real part. Okay, or you can say here from this equation only one will be in the right side of the s plane. Okay, and one will be in the negative side. So here s equals to plus or minus 2j are the two roots on the imaginary axis. So two roots on the imaginary axis with the zero real part. So what do you mean by zero real part? So when you take the complex term, for example, 1 plus 2j. Okay, 1 plus 2j. This is real part and this is imaginary part. So here when you observe s equals to plus or minus 2j, no, it is only the imaginary part, no real part. Okay, that is what zero real part. Here two roots on the imaginary axis with the zero real part. Roots in the RHS indicated by a sign change, that is s equals to plus 2 as obtained by solution a of s equals to 0. So there are 6 roots. From the equation only we can say that s to the power of 6 means 6 roots will be there. So one will be in the RHS, that is right side of the s plane, and 2 roots will be with the roots with a zero real part. And what about the negative side? So here 6 minus 2 minus 1 equals to 3. So 3 roots will be in the negative side. Okay, 3 roots will be in the negative side, negative of the S plane. So first to find out the positive real part, and next to find out the imaginary if it is a roots with a zero real part, that is 2. And next to your overall is 6 minus 2 minus 1. So you will get the 3, that is the value of negative real part, roots with a negative real part. Next question we shall solve. This question they have asked for 6 marks, 8 marks. Okay. So this question they have asked for 8 marks. Okay. Next question what we discuss is, that is 6 marks. So they have asked it like this: find the range of k for the system to be stable using RH criteria. G of s, h of s equals to k into 1 minus s divided by s into s square 5s plus 9. Okay. So we know that we always write for the closed loop, that is 1 plus g of s into h of s. That is the characteristic equation what we consider. 1 plus g of s, h of s equals to 0. So they have given that g of s, h of s value that you substitute equals to 0. Take LCM. So when you take LCM and solve, you will get s to the power of 3, 5s square plus s 9. That is s is common they have taken, because here k into 1 minus s is there. So you will get s open bracket 9 minus k close bracket plus k equals to 0. So here a0 value is 1 and a2 value is 9 minus k. Okay, and the A1 value is 5 and A3 value is K. That is what? A1, A0 value, A2 value, and this is A1 value and this is A3 value. So s to the power of 0 value A3 again. Okay, this is value is A3. This is value is A3 and this value is A2. Okay, and this is A0 and this is A1 and this value is A3. So next for s to the power of 1, what you will write? 5 into 9 minus k into 1 divided by 5. That is what we have done here. Okay, but we don't know that k range. So from s to the power of 0, k is greater than 0, and from row of s to the power of 1, 45, that is 5 into 9, 45, minus 5 into k, minus 5k minus k, that will be minus 6k greater than 0. Denominator will become 0. Okay. So 45 minus 6k greater than 0, 45 greater than 6k, 45 divided by 6. Okay. So 45 divided by 6 value is 7.5 greater than k. Okay. So k is less than 7.5. So what they are saying is 7.5 is greater than k. So that means k value will be less than 7.5. So hence the range of k for stability is 0 less than k less than 7.5. This is the answer. Okay. In next class we shall discuss with the other problems, and subscribe the channel for more updates.